So you can see immediately why this would be useful. It gives you almost total control over the software environment for that process. It only sees what you want it to see. So why do we care about containers? Well, this is a research university, so we need to have science. And one of the things that we can do with containers is we can share them because science is meant to be shared. And another thing we can do with containers is you can use images on other computers with the same architecture. So importantly, if the experts have built an image, you can use their image on a different computer, which means you don't have to worry as much about installing things. And finally, if your cluster changes, but your image is the same, you're not as worried about it because your process really just depends on what's in the image. It doesn't depend on what other changes may have happened to the cluster. So some clusters like TAC update frequently and it may break your workflow. But if you're in a container, you don't really care about that. So a related concept to the container is called a virtual machine. Anybody heard of a virtual machine? Those are really popular in the cloud, for example. Containers and virtual machines have some similar functions, but there's a one big main difference, and that is that the virtual machine contains a copy of the operating system kernel, which is running, and that means that the operating system kernel has to be given some virtual resources to be in control of because that's what operating system kernels do. So the virtual machine manager is emulating resources for the guest operating system kernel to be in control of. Meanwhile, the host operating system controls the real physical resources. And the container, we don't have that. In the container, you don't duplicate the operating system kernel. You use the real physical operating system kernel. So um, that means containers are more lightweight than virtual machines. They don't occupy as much space in memory. So you can have a lot more containers running than you can have virtual machines running. And that's important for HPC because HPC is often massively parallel. And if you were limited by memory, that would you would not be able to take advantage of all the full cluster capabilities for parallelization. So that's the main thing. So popular container runtimes. Containers have actually been around for a while, but aside from some extreme Linux nerds, nobody really knew about them until Docker in 2013 brought containers to the research world. So Docker made it very easy for researchers to share their software from their personal machines. Uh, but and that works really well, but Docker was not designed for high performance computing. It was designed for researchers on their personal machines. And so to address those issues, we have new container runtimes which are designed for HPC. Singularity and Charliecloud are the ones we're using here on ACES, but of course there are others. So I'll talk about Charliecloud first. Charliecloud is a lightweight, fully unprivileged container solution created at Los Alamos National Laboratory. So Charliecloud is both a container runtime and an image builder. Charliecloud can read and convert Docker images. That's important because the majority of images out there in the wild were created using Docker because it's the oldest. And the file system inside the container is isolated. That's the main point of containers. The user inside the container is isolated. So I previously talked about how containers can have their own view of resources, including what the user IDs are. So Charliecloud allows you to pick a different user ID inside the container and then that maps to your real user ID outside the container. Charliecloud works with high performance cluster technologies mainly because it doesn't try to get in the way of you using them. So if there's something on the host file system you need, you just use it. So we're going to read more in the, well, you could read more about Charliecloud in their manual. We're not going to do that right now. So on ACES, how do you get access to Charliecloud? We have Charliecloud in our module system. So that's just module load Charliecloud. And here's some things you need to know about using Charliecloud on ACES. Charliecloud images can be large on disk. So you need to be aware of your storage quota. Scratch file system has a larger storage quota than home file system. So mainly we'll be putting images there. Some container activities may be too intense for the login nodes because the login nodes are shared. We need to be courteous to others. So for our most intense operations, we will be using compute nodes. And similarly, some container activities may be too input-output intense for the shared network file system. So that's the network file system that's Scratch and Home both live on. So we'll be courteous to others and use a local file system for the large image operations. We'll be covering how we do that in the section where we actually get started. Next, I want to talk about Singularity. So Singularity is a high performance container solution that's designed to be easy to use. And it is presented by Scilabs. They changed their motto. Now apparently it's different than it was before, so updated my slides. The focus of Singularity is mainly to be easy to use, unlike Charliecloud, which is mainly to be simple. And although simple and easy are similar, they're not exactly the same. And another thing you might want to know about is this thing called Apptainer. You may have heard of Apptainer. So story time, once upon a time, a corporation for profit named Scilabs developed a product, Singularity, but you can't just have one version of a product. You have to have tiers. So you've got the community edition, the enterprise, the pro, and the services. And then the Linux Foundation said, wait a minute, did somebody say free? Don't mind if I do. So they have a fork of the free version of Singularity, and that's Apptainer. It's literally just Singularity with the Scilabs branding removed so that it can be in the public, in the open source Linux Foundation. So sometimes you'll see Singularity, sometimes you'll see Apptainer. The only difference is, do you want to be doing business with the corporation Scilabs or not? And that's your personal choice. They do the same thing. So I will use the word Singularity because that's the word that we have been using on ACES. But in fact, sometimes when you're using Singularity, you're actually using Apptainer under the hood. And I don't usually care. So what do we need to know? Singularity is a container runtime and an image builder. Singularity can read and convert Docker images, and the file system inside the container is isolated. These three things are the same things I said about Charliecloud. They're basically just fundamental components of any container runtime. But here's what's different. Singularity doesn't isolate the user inside the container. Instead, your user inside the container is the same as the user outside. So Singularity doesn't provide that feature that Charliecloud provides, because again, sometimes simple and easy are not the same thing. They took a different strategy. So Singularity works with high performance cluster technologies, but not for the same reason as Charliecloud. It's because the Scilabs put a lot of work into manually supporting each of those cluster technologies. So the way they did it is easier when it works than the way Charliecloud does it. And of course, you can read more in the Apptainer manual. The manuals are pretty much the same. Just read whichever one you like. So I need to talk about Singularity on ACES. Singularity is available on compute nodes. It's actually not part of the module system. It simply is installed directly on each compute node. So you don't have to do module load. You just have to make sure you're on a compute node. And the reason for that is Singularity activities are too CPU intense for login nodes, generally considered to be the case. And Singularity images can be large on disk. That's the same thing I said about Charliecloud. And some container activities may be too I/O intense for the shared network file system. That's the same thing I said about Charliecloud. So we're going to move on to getting started. I would like to take a moment to give my voice a break from speaking in case anybody wants to ask a question. Now would be a great time to ask a question.
Good morning. Can you
Good
hear me?
morning.
Okay. So why would anyone want to have both Charliecloud and Obtainer on the same cluster?
Uh, Mainly we support multiple runtimes because then the user has the freedom to choose. Both runtimes can do all of the tasks, but the level of easiness is not the same. So for some tasks, one container runtime will be easier than the other. So the user may have a preference, and uh, that's why we want to support multiple runtimes so that uh, uh, we can give the users the freedom to choose their preference. There are some container runtimes we won't support, particularly the ones that are not made for HPC, can never work on HPC. Um, or container runtimes, I guess if there was one that was not free, we wouldn't use that either. But among the free options that are compatible with HPC, I think we're willing to support as many as we can.
That makes.
Um,
Thank you so much.
I had a quick question.
yes, Rohit, what can we do?
Uh, so there seem to be like a lot of different ways to run your containers or build your containers. So do you have like a cross compatibility matrix or something, or like what images can be used in which will work in which, what don't work, something
Uh,
like that?
that is a good question, and we'll actually be learning more about that later today in the short course. The general answer is um, container runtimes are largely all compatible with each other. I will show you some evidence of that later in the short course, so you can hopefully understand what it is, why I say that.
That's good. Thank you.
Are we all ready to get started? I saw that somebody put something in chat, but I'm scared to click on it because I don't want to crash my Zoom.
Oh, it was just me.
Oh,
Just
okay.
typed the same thing.
Then I think it's time to get started. So we need to log into the ACES cluster in order to do our exercises. So here's one way to get to the ACES cluster. If you start from our homepage, hprc.tamu.edu, you can click on the portal drop-down menu, and one of the options will be the ACES portal. The ACES portal is authenticated through Access, so that's why it has Access also in that menu option title. We also have this link, portalaces.hprc.tamu.edu. I would like to request that my colleague Keegan will drop that in the Zoom chat for your convenience. But if you're scrolling through the PDF along with me, that link is in the PDF. Here's where we are. So you can click directly in the PDF. So once you click the link, it will take you to the Access authentication page where you have to select your identity provider and if you select Access CI as your identity provider, you get the Access CI login. If you select your home institution and you already set it up, then it'll redirect you to your home institution. And if you have already logged into Access recently and your browser remembers that, it may skip all these steps and just take you directly to the portal landing page. The portal landing page is the one that I showed on the previous slide on the right here with the ACES logo and some menus at the top. So I will do that as well. So if I click this link here, open in a new tab, because I have done the access authentication today, it skipped past that and used my token. And so I was able to load the ACES landing page. So I have the logo. It's a little smaller than it was when I took my screenshot. So there's more room for the message of the day. The message of the day is that our maintenance was completed. That's good news. So would everyone please let me know with the Zoom features that you have successfully reached the ACES landing page after you log in. Okay, I'm scared to click on Zoom to find out, but I can see from here there's at least one positive reaction. The last time I clicked on Zoom, it crashed. But if somebody's putting up a negative reaction, I'd like you to let me know so I will know to slow down. So I'm returning to my slides now. And the next thing we need to do is we need to get a terminal, a shell terminal to be more precise. And we just use the clusters menu. So the clusters menu will give you a terminal on the cluster. Currently, we're in the ACES portal, so there's only one option. So we just use it. And that will drop you into a pretty bland, but quite easy to use terminal directly in a browser tab. So you can see in that screenshot, I landed on the ACES login 2 login node. Let's see what happens to me today. Today I landed on the ACES login 3 login node. Let me make my font a bit bigger for you. I'm using the browser zooming in feature. Is this big enough for you to read on my screen?
Yes, it's really big.
Okay. I've done some tutorials where people forgot to do that and it was really hard to follow. So I always make sure to do that. Okay, so the next slide in our slideshow is telling us that we need to set up the Charliecloud environment. So as I previously stated, Charliecloud is available through the module system. So that's just module load Charliecloud. It is lowercase. You can copy and paste this line out of the PDF, but I would prefer that you type this one by hand because it is simple enough that you can probably do it on the first try, and it's good practice to spell that word Charliecloud with your own fingers at least a couple times. Module load Charliecloud. Actually, what I want to do is clear my screen and then do that. Module load Charliecloud. Okay, so there's no output if it's successful. So if you want to see the result, you need a second command module list. And it says that I loaded Charliecloud 0.33. Okay, so the next activity is to get a Charliecloud image and inspect the Charliecloud image. So for that, we're going to be using the chimage executable provided by Charliecloud. Its job is to handle images. Are you all ready to execute these commands on your command line with me? So this is one of the ones where it might be a good idea to get into your PDF and scroll down to the same page. I'm on page 24, I believe. And that way you can grab these lines and copy and paste them if you're having trouble spelling them correctly. Things like a space or a colon or an underscore can easily be a snag. And I don't want you to struggle with this. This is meant to be a really quick exercise. So you don't have to execute chimage help, but if you did, it would tell you how to use it. So the first command is chimage pull, which fetches images from the internet. And the image we're going to fetch is named Alma Linux. Alma Linux is just a lightweight Linux distribution that is meant to live in containers. So the pull will be quick. So you can just use your operating system's copy and paste. And I'm going to hit enter here. Oh, I got the error. So this error happens when you previously used a different version of Charliecloud. And then you have to, your Charliecloud directory can get out of date. So I'll just clear it and start over. There we go. So chimage pull Alma Linux 8 ran for a few seconds because this is not a very big image. And it says done. That's good news. So that means this image should be somewhere on disk. So how do we find out where it is on disk? Let's go back to my slides. On my slides, we have a chimage list, which will tell us what images Charliecloud knows about. It says it knows about Alma Linux 8 because I just pulled that one, so it knows where it is. Where actually is it though? So when you pull images, they go into a storage area named Charliecloud image storage. And so there's a variable chimage storage that points to where that directory is. So let's just investigate that quickly. You can tab autocomplete that variable because this terminal has directory autocompletion enabled. Just a useful feature. So if we echo the chimage storage, it says it's a directory. If we ls the chimage storage, we can see that it's got some directories. And in the image subdirectory, we can see the Alma Linux 8 is there. So I found it. This is, you don't have to do this every time. This is just for your educational value to try to understand what's going on under the hood. So one of the things that you might take notice of is that the image storage location is on the temp file system. The temp file system is a local file system to this node. And the reason for that is because Charliecloud image operations are often too IO intense for the shared file systems, the scratch and the home. So we keep our images in temp while we're working with them. So while we're pulling them and inspecting them, so that we don't cause a problem for everyone else on the cluster. And I will show you how to move the images to the shared file system, which will be necessary for doing HPC. That just comes later. For now, they're in the local file system. Is it clear what I'm saying, that temp is the local file system for this node? So if I logged into a different node and investigated this area, it would not have the same content. So now we need to launch a container. So recall, a container is a process. So the process I want to launch is just a bash shell terminal, similar to the one I'm already using. I just want the bash to be containerized, so it has a view of the resources that I get to control. So let's take a look at a file that could be different on the file system versus in the image. So the etc. Red Hat release file exists on the real file system, and it also exists in the image. I happen to know that because I know something about this node and I know something about Alma Linux. So we're going to compare. So if I clear my screen, if I cat the etc. Red Hat release file, it says that this node is running Red Hat Enterprise 8.9 UTPA. But in the image, that may have a different content. So we're on slide 25 now. So in the image, we're going to see it might be different. So how do we launch a bash terminal in the image? We're going to use the chrun tool that launches containers, so processes that see the image instead of the real file system, so that it's chrun, the name of the image you want the process to see, and then the name of the process you want to launch. So in this case, bash. So we're going to go chrun Alma Linux 8. This one doesn't autocomplete. Bash. And now it returns to my prompt, but the prompt has changed. Instead of the ACES login prompt, it's now a generic bash prompt because the image doesn't have any knowledge of what the cluster prompt should look like. So we just got a generic one. And now that we are running a terminal that sees the image, we can inspect that file, the Red Hat release file, and see what it looks like in the image. So we can see that the Red Hat release file in the image is Alma Linux 8.10 Cerulean Leopard. And then since I'm done with this activity, I type exit to shut down this process. Exit is just the bash command for I'm done. And we return to the terminal that's not a container. So we back to seeing the regular file system. Was anybody able to complete this exercise along with me? Please give a reaction in the Zoom if you have been able to do this. And let's do the next activity, which is the same thing but with Singularity. So I previously said that Singularity is only available on compute nodes. So that means we need to get to a compute node. There's more than one way to get to a compute node, but given we already are on a login node, the way to get to a compute node from a login node is to use srun. So this is one of the commands you probably should just copy out of your PDF. I'm on slide 26 now. So I'm copying srun. But also, because we're doing this live, we're going to add the reservation equals training. That goes before the word bash. So the full command will be srun time mem pty reservation training. Those can be in any order. They just have to be before the word bash. Okay, and after a few seconds, Slurm pairs me up with a compute node. So I landed on compute node AC20. So you can see previously I was on the login node login3, and now I am on compute node AC20. So now we have access to Singularity. So I can do something like which Singularity, and there it is. You don't need to do module load because Singularity is installed in the root area for the Linux distribution. And we can check what operating system is running on the compute node the same way. We can cat the etc Red Hat release file. It's the same thing. It's Red Hat 8.9 UTPA. So in order to set up working with Singularity, we need to do a couple of things. The first thing we need to do is set up a space for Singularity to save images. That's similar to what we had with Charliecloud, but the name is a little different. Its name is Singularity Cache dir, and currently that variable is not automatically exist, so we will have to set it ourselves. So in your PDF, copying and paste this code into your terminal. So $tempdir is a variable that Slurm gives us that points to a location on the local disk of the node. So if I check the value of Singularity Cache dir, I can see that it points to somewhere in the temp file system. That is the point. The point is that we're going to keep our images in the local file system of the compute node so that we don't cause a problem for the shared file system. And then the last thing we needed to do is we needed to do module load web proxy because compute nodes are not directly connected to the internet. We need a proxy to reach the internet in order to fetch a container image. So with Charliecloud, I demonstrated fetching the image and running it in 2 separate steps. In Singularity, I'm going to demonstrate doing both of those things in 1 step. There's no fundamental difference doing it in 1 step or 2. It's just a convenience that many runtimes provide, which is that it can do the 2 steps with 1 command. So we're going to try out the Singularity convenience feature where we do both steps at the same time. So we're going to type this command, Singularity shell, which is the Singularity command for start a terminal using the specified image. So and then the image, we're going to specify a location on the internet. So for Singularity, you have to specify what image repository you're going to search from. We're going to search from the Docker image repository, and Singularity knows where that is, so that's not a problem. And then the path is just basically the name of the image. The 2 slashes for it's on the internet, and then the name of the image. Same image, we're going to be pulling Alma Linux 8. So I'm on slide 27 now. So I'm copying Singularity shell Docker Alma Linux 8 into my, actually, let me clear my screen first, and then I'll paste that into my terminal. And now Singularity is fetching the image. It will take a few seconds. This is not a very big image, but Singularity is not particularly fast. So I will wait a few seconds. I don't know why Singularity does this a little slower than Charliecloud. It's a mystery to me, but they're both fast enough that it's not a problem. We just have to wait a few seconds. And now it's done. And you can see that after creating the file, Singularity has also launched my container process. So my prompt has changed. My prompt is now Singularity caret. Is that what that's called? To tell me that I am now seeing the image instead of the file system. So we can confirm that by inspecting the Red Hat release file to see what files are currently being viewed by this process. And in fact, it's the same image that we had before with the Alma Linux 8.10 Cerulean Leopard. And don't forget to exit your Singularity container process. And don't forget to exit the compute node srun job. And now I am back on the login node where I started. Congratulations, welcome to containers. If you are following along, then you have done something that many people would consider to be very mysterious, and I'm trying my best to make it feel not so mysterious. It is now, I have decided, time for a break because it is 10:52. We have completed our introductory activity where we just turn on the container runtimes and make them do something simple, and my voice needs a break. So let us resume at the beginning of the next hour, 11 o'clock. Could someone drop in the Zoom chat that we're on break until 11 o'clock? Thank you very much. Howdy, folks. Welcome back. Welcome back from your short break. Do we have any questions before we move on to learning how to work with images? Okay, I will now move on to working with images. So the first images we're going to work with are the Charliecloud images. So Charliecloud container images come in two main formats. The first is the directory format. So that's just the native format of the image, which is files and directories, and you put them in a directory on the real file system. And the second kind of image is a single file. So for the single file, HPRC supports the squashfs file format. We'll learn more about squashfs file format on a later slide. In order to convert between the two formats for an image, we have chconvert, which can copy an image from one place to another and change its format. So if you are using chconvert and you are copying to or from a directory image format, then the way that you specify that is you have the image name end in a slash. So that guarantees that Charliecloud understands that the target is a directory because only directories end in a slash. So the main feature of directory format images is that they are writable. You can easily add more files to them, delete files, whatever you need to do. The main caveat of directory images is that reading and writing the individual files are slow, especially over a network. So in order to avoid that, we put directory images on the high-speed temp file system. And that's what we've already been doing. The images in chimage storage are also directory images, but you refer to those by name without the trailing slash because those are the ones that Charliecloud is in control of. So we don't read them directly. We let Charliecloud find them. So let's practice converting an image to the directory format on the login node. So we need a place to put it that's in the local file system. So go ahead and make a directory on the login node for yourself. So I'm on slide 32. So if I'm copying from slide 32 into my terminal, I'm currently on the login node. actually already have one of these, so that's why it's an error, because I previously did this. So you just make a directory for yourself, which you're allowed to do on the local file system. And then we're going to execute chconvert. And what we're going to do is we're going to take the image out of the ch image storage. We refer to the image that's in ch image storage by its name according to Charliecloud, and we recall, I guess I could demonstrate that quickly. In case you forgot, that's what ch image list tells us. So we have ch image list alma Linux 8. So that's the name of the image in the storage, and we wish to convert from that image. So it's source first, destination second, and the destination is a directory that will be created. So you can name the directory anything you want. You can name it alma Linux foo, or just change the name because it's arbitrary. It's just a directory. So chconvert, essentially what it's doing here is making a copy because it was already in the directory format. It was just in the storage and now it's somewhere else. So what can we do? We can investigate the image to see what's there. Now that it's just a directory, we can hit it with ls and we can see what files are in it. This looks pretty much like a normal Linux distribution file system. It even has some symbolic links. It's not the same as the root file system on the login node, by the way. The login node has a few extra directories like this ADM and this scratch. Those are not present in alma Linux. So what can we do with the directory image? We can edit the directory image. So that means what you need to do is you run a process that's capable of creating files, and then you add the write flag to tell Charliecloud that you want that process to be allowed to make changes to the image that it sees. So we previously did chrun alma Linux bash. Now we're going to do ch1 write path to the directory image bash. So I'm on slide 33. I copy and paste this into my terminal. Oh, it's because I renamed it. Haha, silly me. You have to put what it's actually named. Okay, so now I have a bash terminal. It sees this directory image, and I can do things to it. So I can make a directory. What did I want to name the directory again? Okay, my_dir directly in the root of the image. That's a bit scary. Well, it worked. You can see it's there. And if we leave the container image, if we leave the container, so now we're back to seeing the regular file system, you can see that my dir is not created in the real root of the real file system. So it was created in the root of the image file system. And if we run again out of the same container, but without the write flag, because we're not going to be writing a second time, I can inspect the file system and I see that my dir is still there. So leaving the container and then starting it again, the file persists because the directory image, it was created in the directory format image. And don't forget to exit your container process when you're done with it. Has everybody had a chance to do this exercise? Can you give a react in Zoom if you have done this exercise? I don't see a react, so I guess that means you're still working on it and I should wait. Whenever you finish doing this exercise, would you please give a react in Zoom so that I know it's time to move on? One reaction in Zoom. Thank you, Frank. Okay, so I think everyone who wanted to do the exercise has done it, so that means it's time to move on. Let's learn about the other file format. So SquashFS is an open source file format that's mainly used for file system images. The whole file system becomes one single file, and the image name should end in .sqfs, which is your hint to Charliecloud what file format it is. So the main property of SquashFS images is that they are read-only. They are compressed, so you cannot easily add anything to them. But the benefit of the single file is that the reading operations are very fast over a network file system. So it's safe to put your SquashFS images on the Scratch file system. And that's important for HPC because sharing your file system across nodes allows you to do your work in a batch environment. So let's make a space in your Scratch directory for storing your images. Do you all know how to navigate your Scratch directory on ACES? That's $, capital Scratch, autocomplete. And this is just a, this is your personal Scratch workspace. And so I already have a CH tutorial. Wait, what did I want to name it? C tutorial for containers. Okay, so I already have a containers tutorial directory because I've done this before, so I'll just erase it. And then I will recreate it. It doesn't actually matter where you put these things, we just need somewhere to put them. So now I am in a directory that I have created for the purpose of putting some images in that directory. Now it's time to convert the directory format image that we were working with earlier into a SquashFS image. So I'm going to go to my slides and scroll down to slide 36. And I'm going to copy and paste this command into my terminal. But of course I have to fix this because I changed the name, remember? So now I'm converting my directory format image into a SquashFS format image. And since I didn't specify a path, that's implied in the current directory. Lots of output, and then I can do ls, and I see that my file is present in the current directory. So what can we do with the file? Well, we can run containers using that file as the image. So we know how to do chrun, name of an image, but this time it's the file name of a SquashFS image file, and then which process. So chrun almalinux.sqfs bash. And then we can investigate the file system, and you can see that that directory that I made earlier is still here. So when we converted the directory format image into a SquashFS format image, it gets the updated files. So the file I created is now present in that single file format image. And don't forget to do exit when you're done in that container. How are you doing, students? Are you able to follow along? I'm afraid that my Zoom is not going to tell me if you're doing things, because my Zoom is like, it crashes if I click on it. I do see Frank is giving the thumbs. Thank you for following along, Frank. Would you let me know if you had a question? So now we know how to do saving your image in Scratch in Charliecloud. Let's learn how to do the same thing with Singularity. So Singularity also has two main formats. You have the directory format and you have a single file format, but it's a different file format. Singularity uses a format named SIF, Singularity Image File, instead of squashfs files. So the Singularity build tool is used for multiple things, including converting image formats. So the sandbox option is used to create directory format images. Now we need to get onto a compute node to do the Singularity exercise. So I am now on slide 38. So I'm scrolling to slide 38 and I'll copy this. And I'm going to add the reservation equals training because I'm following along live. This reservation exists right now. It won't exist later, but it exists now. And now I am back on AC20. See AC20 here? I'm on a compute node. And now we can repeat our setup. Recall we previously had to do some setup. Actually, if I scroll back, since I'm on the same node I was on before, if I scroll back, my my shell history remembers these commands so I can repeat them. Otherwise, you're just you're going to copy and paste them out of the PDF again. And we need to make sure we're still in our Scratch area. I don't actually need to change directory because I'm already here. srun will leave you in the same directory if that directory also exists on the target node. In this case, it does because it's in Scratch and Scratch is mounted on all the compute nodes. You got back to a compute node, Frank?
Not yet. Hold on. I got the error message.
Okay.
Okay, loaded the web proxy.
Okay. Then I think you're ready to build some Singularity images. So the first thing we need to do is we need to fetch an image from the internet because this compute node doesn't currently have one. And this time we're actually going to go the other way. So, and with Charliecloud, we converted from directory to single file. And for Singularity, I'm going to showcase the opposite. We're going to go from single file to directory. And you can go both ways, of course. I'm just have to pick a little bit of some of each for variety. So we're going to fetch the Linux 8 from the internet, and it's going to be saved on disk in the SIF format. So the command for that is Singularity pull, and it's in the other order from Charliecloud. It's destination first, source second. So on slide 39, Singularity pull, almlinux.sif, docker almlinux 8. We know from before that it takes a few seconds. It is the same image being pulled, so it should take the same amount of time. The only difference is where is it being saved. Previously, it was saved in Singularity's cache. Now it's being saved on a specific location in Scratch because we asked it to do that. Okay, so I have my prompt back and I go ls and I can see that almlinux.sif is now present in my current directory. And the next command is the Singularity build command. The purpose of this is to convert from one format to another. And the sandbox option tells Singularity that we're converting to a directory format. So it's sandbox path to directory for the destination, and then the source is the SIF file that's present in the current directory. So I copy and paste this into my terminal. And very quickly, we now have a directory format image, and it's told us where it's put it. It's put it where I asked it to put it, which is a location on the local disk named tempdir, which is a location that Slurm sets up on the local disk for where you can put things. And I've named my directory Alma-Linux, so now it's temp job Alma-Linux. And that's where the image lives. So what can we do with a directory format image? We can edit the image. So the syntax is similar, but not exactly the same as Charliecloud. We use Singularity shell to launch our bash process. We provide the writable flag, it's spelled a little differently. And then, of course, the path to the directory image. So now I'm on slide 40. And we'll repeat that exercise where we create something and then see if it's still
Hold on,
there.
that does not finish that sandbox yet.
Okay, please do finish the sandbox.
Okay, go ahead.
Okay, so if you hit that directory with ls, your sandbox, it should look like an Alma Linux root file system, correct? So we would like to edit this Alma Linux file system. So on slide 40, we have the Singularity shell writable command. I paste that into my terminal. And it has some warnings about some directories that don't exist in the container. That is correct. They don't exist in the container. But thankfully, these are just warnings, so we can proceed. So let's make some stuff. What would you like to name this directory? Frank is the best. And then I will shut down the process. And now we would like to check to see if our changes are still there. Singularity shell, that same directory image, but without the writable flag because I'm not doing any edits right now. I just want to check to see if Frank is the best is still present in the image, and it is. So now I can do exit. Does this work for you, Frank?
Oh, hold on, I'm still in the create Frank is the best, not there yet.
Okay. Okay. So the experiment works where your files are still there on the second time you use the shell?
Yes.
Very good. So earlier I got a question. Are all the container image formats compatible across runtimes? That's an interesting question. We can answer that question. So currently we have a directory format image that Singularity has just built for us. Can we read that image using Charliecloud? Let's try the experiment. So 41 is, we'll find out on the compute node. So we're on AC20, right? Module load Charliecloud. Chrun tempdir Alma Linux bash ls slash, and if you're seeing on my screen, Frank is the best file is there, and the container works correctly. So Charliecloud is able to read this directory format image that Singularity created. And then don't forget to exit your container process when you're done with it. I see a thumbs up in chat. So, I'm sorry, in Zoom. So I think that means you completed the activity. So the general takeaway message is, if you can find a Linux distribution from anywhere, like you could go directly to the Linux distribution's source code and copy the file tree onto disk, then any container runtime will be able to run that directory format image and convert it to its favorite directory format, its favorite image format. So fundamentally, all of the container image formats are compatible. There may just be some steps to convert from one to the other. Here's an exercise where we fetch a Linux distribution's file tree directly from GitHub. Are you interested in this one, Frank? It's kind of optional. It's a demonstration, basically. You wouldn't really do this for research purposes.
Okay, that's okay.
The point of the demonstration is that you unpack the Alpine distributions tree into a directory, and then you can use it like it's a container image, and both Charliecloud and Singularity can read it. So that's what the demonstration does, but we don't have to do it. So the next topic is container recipes. I would like to take another brief break before we launch into container recipes. Howdy, Frank. You still with us?
Yes.
Welcome back from your break. Let's learn about container recipes. So, we have practiced modifying containers by hand, container images by hand. But this is bad practice because the information about what steps were taken is lost. After you save your image, nobody knows how you did that. So it's better to write down the steps to build a container image, and that's called a container recipe. And then you tell your container runtime, do these steps to build this image. So Docker uses a recipe file named Dockerfile, and Charliecloud supports Docker files. Singularity uses a different recipe file called a definition file. The syntax is different, but they all have the same purpose, which is here are the steps you need to build this image. And you can therefore execute the steps again to rebuild the image. If you need to make some changes, then it's easy for you to remember what you've done. So let's suppose that we wish to build a container image that has Python 3. So if you were on your personal machine, you would do yum install Python, and that would install Python on your computer. But you can't do that on HPC because that requires super user privileges, which we don't have. Even I don't have. So I can't do yum install Python directly on the HPC. But we can install Python into a container image. And then in order to use Python, we need a little Python script that says hello world to test the Python. So we need an image that has the base file system of a Linux distribution. So I picked Alm Linux because we're familiar with that one. Then we want to install Python and create this file. And that's the recipe expressed verbally. And now we need to convert this recipe into a recipe file that a container runtime can understand. So First, I'll show you how to do that in using a Docker file. So with the Docker file, we need 4 commands. We need the from command, which says we start by building on top of an existing image. And generally, when you're building containers, you want to start on top of an existing image because the existing image will have your install tools like yum. And it's really hard to install anything if you don't have an install tool. So we start from Alm Linux, and then the next thing we need to do is we need to run the install command yum install Python. And the next thing we need to do is copy our hello world file into the image. And the last thing we need to do is make the image, the hello world file, executable so that we can test Python with our runtime. So these are the 4 steps in the Docker file way of doing this recipe. Is it clear why these are the 4 steps in the Docker file?
Yes, okay.
Then let's do it. So you need to go to your Scratch area and set up a workspace where you have a directory where we're building an image. And we need 2 files. We need hello.py and we need Dockerfile, and these will be their contents. So I'm scrolling down to slide 49, and I'm going to go back to my ACES dashboard. And instead of using the terminal, I'm actually going to use the file navigator that the ACES dashboard provides. So I'm going to go to my Scratch area, and I'm going to change directory into the C_tutorial, which is where I'm putting these things. And now I can set up this space. So I needed a directory named, what did I want to name it again? Hello in the Docker. This is the Docker file variant, and then we'll do the other step later. So we need 2 files. We need a hello.py, and we need a Docker file. And then I can do the 3 dots edit and paste my code into the file.
Can I get into
Because I'm
this
still in
graphic
Lua.
interface also?
Huh?
Can I get this graphic interface also?
Yes. So if you're on the ACES portal, recall the ACES portal's URL, portal ACES, hprc.tamu.edu, putting that in the Zoom chat. If you navigate to there, then we have the files menu, and the files menu will give you a graphical interface for navigating files. So the Scratch option will start you in your Scratch directory, which is helpful. And that's how I'm going about creating these files. So I switched mode to Docker file on the Docker file to get syntax highlighting, and I saved it. And then I'll do 3 dots edit on hello.py and switch mode to Python to get Python syntax highlighting, and copy my Python code in there and save it. And now I'm back on my shell, and I can navigate into that directory, and I can see that those files are there. Oh, there's a problem with the file. It's because of probably, I was expecting there to be like a new line character at the end of the file, but there isn't. Oh, well, that's not the problem. So anyways, the files are there now. It's just that cat didn't add the new line character at the end I thought it would. Okay, so I guess I need to give you some time to set that up. Are you give the the graphical file navigator a try? I find it to be convenient.
Uh,
We have the new file, new directory
hold
option
on,
stuff.
where is the dashboard, the original? Yes, what is this page? Portal. Click that portal, so let me see the URL. Hold on, let me type in.
You just need this part.
Hold on.
I'm putting it in the Zoom chat. The rest of this is automatic, so if I delete it, it just comes back.
Okay, I get into the tutorial. Yes.
So you use the navigator and you find your tutorial directory, right?
Yes.
Now you can do create new directory, navigate, create new file, 3 dots to edit files, and you can set up those files that we need. I copy and paste the contents out of the PDF, and I put them in boxes in the PDF, so when you're copying and pasting, it's easy to get just the lines you want. Does that make sense?
Yes. Create separate two files, right? The hello and the Docker file.
Yes. So your file navigator would look like this. I use the new directory and click and then the new file option.
How do I move these two files into that hello SRC folder?
If you need to move a file, you just select the files and then you click the copy move button. And then you navigate into the directory you want to move them to. And then you see the panel on the left is like your clipboard that says these are the two files you want to move. You get into the place where you want them to be, and then you either click copy or move. Does that help?
Okay, I got it.
So now you should be able to CD into that source directory and see that your files are there on the command line. Does that work?
Yes.
Okay, then we are ready to build the container. So this is a Docker file, so we can use Charliecloud to build the container. And the command will be chimage build, which builds containers from recipes. And you need 3 options. You need to give the output a name. So -t is the tag option that says the output will be named hello. You need the input recipe file, -f name of the recipe file. And finally, you need a context directory, which will just be the current directory. So dot for current directory. That's to tell Charliecloud this is where you will find the source files like hello.py. You'll find them in the directory, the current one. So on slide 50, I can copy this line, paste it onto my terminal. Looks like it had to fetch Alma Linux from the internet. That's fine. Now it's running yum, which again has to fetch things from the internet. That's fine. And it says grown in 4 instructions. And I can actually see on my secret side window that I have that you're also running these commands. Well, I don't know what commands you're running, but you're doing something on the same node as me.
Yes.
So let's do, and where, do you happen to remember where Charliecloud keeps images that it makes? In CH image storage, right? And do you remember the command for checking what images are there? It would be ch image list. So now we have Alma Linux 8 and hello. It actually downloaded Alma Linux 8 because it knew it needed it when it read the from statement in the Docker file. So that image is also in the image storage area. So how do we test our container image? We would like to be able to convert it from the storage area to a hello.sqfs. And I actually want to put that, I guess it doesn't matter where you put it. I think I'm going to put it here. So that would be ch convert hello.sqfs. And I'm going to put it in the C_tutorial directory. Did I miss anything? Going from memory. Okay, that looks correct. Okay, so do you see where it says parallel make squashfs using 96 processors? That's why we don't want to do this on a login node, because if you're using all the processors on the login node, it's kind of rude to the other users. The login nodes are shared, but the compute nodes are dedicated for the people who have been assigned by Slurm. So we know it's fine to do this on the compute nodes. And now we want to execute hello.py, right?
Hold on, not finished yet.
Yeah, you still got converting. Okay, so now we're on slide 51 and we're executing hello.py. Now recall, in our recipe, we copied hello.py from outside the container to the root of the image. So if we did like bash ls root, it would be there. It would be at the root. So that's how we know to call it from root/hello.py, because that's where we put it. So we can execute hello.py from the hello.squashfs image, and hello world comes out. And another thing we can do is we can ask Python what version it is. We can ask Python 3 what version it is. And also on the compute node, we can ask Python 3 what version it is, and you can see it's different. So in the container image hello.squashfs, we have Python 3.9, which is the one that was in our recipe. But on the compute node in the root file system of the real file system, the real physical file system, there's Python 3.6. So now you begin to see the power of being able to install whatever you want, even if a different version is installed on the compute node. Does this test work for you?
Hold on, there is the error message says the Python no such file or directory.
You had to execute Python 3. So when it installed Python, it created an executable named Python 3. It didn't create an executable named Python. And that's so that you don't accidentally get Python 2. We really don't want Python 2, right?
Okay.
You could always create symbolic link Python to Python 3 if you want to. That's just an option for you. It just didn't do it by default.
Got
the
it.
default node link, but you could create one. It's not a big deal. I just forgot. You have to include the letter 3. Welcome, Sabrina. I see you've just joined. Are you interested in learning about containers? We've just learned about Docker recipes, and we were about to move on to definition recipes. So, Frank, we previously wrote a Docker file. Now let's write the same recipe using the definition file. So that's the one that Singularity uses. It's very similar 4 steps, but instead of one command at a time, the definition file is organized into sections. So you have the bootstrap section, which says where on the internet we're going to go look for the base image. You have the from section, which is what is the name of the base image. You have the files section, which is a list of files that need to be copied from the source area into the image. And if you don't provide a destination, then the default destination is just the root. And then the post section is a list of commands that you need to run. But instead of having run yum, run chmod, it's just one section named post, and all of the lines are meant to be run so that it's organized. I guess it's nice that it's organized, but it is more for us to type. So now we need to set up the workspace. I'm making a different directory this time. Instead of .docker, it's .def, because now we're building from a definition file. So I'm going to make a new directory, hello.src.def. I actually want to copy this hello.py, so I'm going to select hello.py, copy, navigate into hello.source.def, click copy again, and now I have a hello.py, so 1 down, 1 to go, right? Pretty convenient. And now I want to make a definition file. It doesn't matter what you name it, as long as you remember, I named it definition. And 3 dots edit on definition, and we'll paste in the contents of our definition file. Copy, paste. I don't know if this white space matters or not. There's white space in the image in the PDF, but I don't see white space in my file editor. I don't know if the white space matters or not. I guess we're going to find out. So I clicked save. And how about you? Do you have these files now?
Hold on.
Yeah. You take a moment to catch up.
I put a tab front.
Okay. I'm sure it's fine. So your files are ready?
Yes.
Then let's execute the build command. So we need on our command line, we need to navigate into the hello source with the definition file. And then we need to execute Singularity build. And for Singularity build, we're using the fake root option because Singularity, you need to be able to tell Yum, yes, it's okay to install even though my username is not root. Remember we learned earlier that Singularity does not change your username inside the container. So inside the container, your username will still be FS, a bunch of stuff, right? So then Yum says, wait, you're not root, you don't have permission. So we need a fake root option to like convince Yum that it's okay to try to install, even though you're not root. And then hello.sif is the result we would like to build. and then definition is the name of the file we would like to build from. And we need to be in the same directory where the source files are so it can find them. Now, I believe we already recently pulled the Alma Linux 8, so Singularity should be able to recycle the copy that it has in the cache and go directly to the yum install step. Okay, I can see that your commands are still running, and it looks like they just ended. Is that accurate?
Yes.
Okay, then let's move on to testing the image. So we're going to be using Singularity exec. We previously did shell because we wanted a shell terminal, but right now we want to execute a command that isn't shell. So we need the Singularity exec, which allows us to provide the name of the command we want to run. So it's Singularity exec, the name of the image file, and then the command you want to run, which is /hello.py. And that is on slide 55. And we can repeat the same exercise we did before. Oh, we can repeat the same exercise we did before where we check the Python version. Yes. So Python 3.9 is installed in that image. That test work for you?
Hold on.
I forgot to put hello.sif in the parent directory, which is where I wanted it to be. Oops, my bad. But it doesn't really matter. It's just wherever it is. So that actually concludes our short course. We're going to be finishing a little early today. I would like to thank our supporting grant funding institution, the National Science Foundation. So we have awards for ACES, which paid for the compute cluster we used today, Sweeter, which previously paid for some of our development work, but Sweeter no longer is active. Faster, which similarly previously paid for some development work and no longer active. And the staff and students, like my colleague Keegan, who has been running our Zoom session, and also the Access CSET pilot program, which paid for me to go to the supercomputing conference as a reward for building this material. So I went to Supercomputing 23 after I built this material in 2023. And you get the updated version today. So I would like for you to take our short course survey. So that's a QR code if you want to take a picture of your screen, or you can just click on the link that I'm pasting in the Zoom chat, or the link that's in your PDF. But we would appreciate it if you would take our short course survey to let us know if you found it to be useful. And here are some more facts about how you can contact us. So we have a help desk email and a help desk phone if you get stuck. And we will, the help desk workers know that if you've got a container issue, that they need to direct you to our container experts, which is mainly me. So you can get the help that you need.
Your slides are not sharing and showing right now, Richard.
I believe I'm showing the QR code with the survey.
I don't see it.
Yeah, I can find from your slides. That's no problem.
Well, I'm not actually surprised, Sandra, because my Zoom is very broken today. I updated this morning and it keeps crashing. Yeah, if I literally am afraid to click on anything because I think it'll crash again if I do. But our student Frank, he has the slideshow in his browser, so he can navigate
Yeah,
down
I
the
can
slide.
do it. One more. Please go back to the very initial after I log into the access, and then how do I get into the ACES? I forgot the procedure.
Is it this slide?
Previously, the login authentication from the access.
This slide?
Yes. After I log in from here, and then how do I get into your ACES?
So you just need to, you can use the portal menu or the portal URL.
Okay, so this is a totally separate. I'm a little bit confused. The authentication is in the access, right?
Yes, but it's a redirect. The redirect sends you to access, and
Yeah,
then
how
it
do
sends
I
you back.
redirect to here?
Yes, but you have to start from one of these links if you got the redirect. Otherwise, you can log in manually to access and then go here. I can show you what that looks like. If I start a window with no cookies, right?
Yes.
Then I can go to accessci.org and I can log in using
Yes, that is the first.
AccessCI,
Yes.
which since I have no cookies, I'm going to have to type everything, right?
Okay.
Give me a second. I redirected my access into my home institution because I find it convenient. So if I just, then I should take me back to access because that's where I was. So I was at access, and then starting from access, if I have logged into access, if I now try to get to the ACES portal, it will see my cookie and it will skip authentication and I'm directly in the portal because it uses the same token. I got the token from logging in here and it's in the browser, and now I can go directly from the link to, well, I misclicked, but this link now can take you directly to the dashboard because it sees that token in your browser cookie and it just reuses the same token.
Okay, so the token is in the browser. So after I authenticate from the access, and then I type in a portal HPRC Tamil at edu, and then this page.
You have to do portal ACES. If you type in portal, you end up on this page and there's no button to click on because this one is not for the access authentication. This one is for the NetID authentication.
Okay, repeat again.
If you type portal, if I type portal.hprc, this is incorrect. This is a real URL, but it is not the one that goes to ACES. It takes me here and there's no button for ACES. If you want to get to ACES, you have to type portal-ACES. If you're not used to authenticating with access, it is a bit funny.
Okay, got it. Thank you very much.
No problem. Are there any other questions I can answer for you today?
That's all from me today. Thank you so much.
Okay, I hope you have an excellent day, and I think we'll be shutting down the Zoom session in a few minutes. Good morning, Sabrina. Is there anything I can help you with?
No, that I ended up seeing the different time zone and I came in late. Will you guys be posting a recording on this?
We will, but also our previous recordings are already on YouTube. Can I help you find them?
Yes, I will. Thank you so much.
So, if I'm on YouTube and I'm searching for HPRC, you can go to our well, I can't because I have YouTube blocked, but you can search for HPRC on YouTube and find the previous Fundamentals of Containers recording, which is almost identical. I think the only significant difference is if you decide to do this specific exercise, the URL is different. I had to update. Yeah, I have to update this URL every semester because it keeps changing, but the rest of the content is the same.
Okay, perfect. Thank you so much.
No problem. Oh, am I sharing my screen?
No.
Oh, well then you're probably confused about which URL I'm talking about. Sorry, let me share and okay, so you need two things. One is you need this PDF, which can be found on the course homepage. So when you registered, you would have been on a course homepage, this one. Oops, no,
Mm-hmm.
this one. And the PDF is here.
Okay.
So you need the PDF because it's got everything you need.
Okay, perfect.
And then in the PDF, this specific exercise, the URL will not be the same as what's in the YouTube video. Because I have to change this one every semester. So the PDF has the correct URL from this semester, and the YouTube will have an old URL. So that will be the only difference.
Perfect.
But it should be possible for you to do all the steps. Oh yeah, and if you're not following along live, there's a couple of slides that say if you're following along live, add this reservation training. You won't use that because you're not following along live. Does that make sense?
Okay. Yeah. Perfect. I appreciate it. Thank you so much.
No problem.
Have a good one.
Have a good day.